In this video, we have 5 equations to solve involving absolute values. And let's look at the definition just to clarify this. For any real number x, the absolute value of x is equal to x if x is either greater than or equal to 0, and it's equal to minus x if x is less than 0. So if x is negative, a minus in front of it makes it positive. So this is telling us that, of course, the absolute value of any number is always greater than or equal to 0. It's never going to be a negative number. Absolute value of positive 5 is 5. Absolute value of a negative 5 is the opposite of that, because it's negative, that's positive. And of course the absolute value of 0 is 0. So for the first one, we have the absolute value of 2x is equal to 6. Now we could factor the 2 there and write this as absolute 2 times absolute x. But absolute value of 2 is 2, so 2 into 6 is 3. So we could write this as absolute value of x is equal to 3. And again, based on the definition, then absolute value of x can be a 3 or a negative 3. Check it out. 3 times 2 is 6. Absolute value of positive 6 is 6. Put a negative 3 there. Negative 3 times 2 is negative 6. Absolute value of a negative 6 is the opposite of a negative 6, which is 6. So it checks out. And we could have left this the way it is and just say 2x is equal to 3, or 2x is equal to 6 rather. 2x is equal to negative 6. Still comes out the same. So that's the answer for the first one. So again, 2x, absolute value of 2x plus 3 is equal to 5. Simply means that this expression here has to be 5, because the absolute value of 5 is 5. Or this could be a negative 5, because the absolute value of negative 5 is 5. So we could write this as 2x plus 3 can equal to a positive 5. Solve this for x then. Be 2x. Add a negative 3 to both sides. Cancels it over here. Negative 3 and 5 would be 2. Divide through by 2. X equal to 1. Quick check here. Put a 1 where the x is. 1 times 2 is 2. 2 and 3 is 5. And the absolute value of 5 is 5. This one checks. By definition of absolute value, 2x plus 3 could also equal to a negative 5. Add negative 3 to both sides here. That'll give us a 2x. And then negative 3 and a negative 5 is a negative 8. Divide both sides by 2. Negative 8 divided by 2 is a negative 4. Check this out. Negative 4 times 2 is negative 8, and 3 is a negative 5. But the absolute value of a negative 5 is 5. So those two check. Okay, and the next one, we got absolute value of x squared minus 2x is equal to 3. So we follow the same procedure here. We can say, okay, this could be a 3. Absolute value of 3 is 3. This could be a negative 3. Absolute value of negative 3 is also 3. So we could set up two equations again. So I'll say x squared minus 2x is equal to 3. So bring the 3 over, adding a negative 3 to both sides, we get x squared minus 2x minus 3. Okay, we simply add a negative 3 to both sides, cancel it on the right side, brought it over, so the right side is now 0. And then we factor this out. It's a quadratic factor here, so we have a quadratic equation, so this factors into x minus 3 and x plus 1 equals 0. And we said each factor equal to 0, get x minus 3 is equal to 0 when x is 3. So that's one possible answer for this part here. X plus 1 can be 0 when x is negative 1. So we had x equal 3 and negative 1. So let's check this one out here. If I put a 3 here, 3 squared is 9, and then 3 here is a minus 6. 9 minus 6 is 3. Absolute value of 3 gives me 3. Okay, for the negative, we put a negative 1 here. That's a plus 1. Negative 1 squared is 1, and a negative 1 here is 2. 1 and 2 is 3. The absolute value of 3 is 3. That checks. So those are the two solutions for that one. Now the other possibility we had, this could be negative here. So let's say x squared minus 2x equal to a negative 3. So then we proceed to solve this one. It's a quadratic, again, x squared minus 2x. Adding 3 to both sides here, we get x squared minus 2x plus 3 is equal to 0. And then the first part's factored. This one doesn't factor. So if we were to use the quadratic formula, bx is equal to, and then it would be minus b. B is negative 2, so this would be a 2 here, plus or minus the square root. Down in the bottom we have 2a. A is 1, so this will be 2. And then the radicand here would be a b squared, so that's negative 2 squared, that's 4, minus 4 ac. And a would be 1, c would be 3. This will be 3 here. 1 times 3 is 3. But notice here, 4 minus 12, that's negative. So this is going to be imaginary. Here we're dealing only with real values, so this one has no solution. So the only solution you can have is this one right here. And you might be able to tell that from right here because notice x squared is always a positive number. And then here, if x is negative, this is always going to be positive. So you're never going to have a negative here. So negative 3 here would not be an option. So that's why we only have this part 1 that gives me a solution. So that's it for that one. Now for the next one here, this will be just like the ones we did then. We have absolute value of 2x plus 1 over 3x plus 4 equal to 1. So we can say that tells me then that 2x plus 1, that is, by definition of absolute value, this quantity could be negative or positive to generate this 1. So 2x plus 1 over 3x plus 1 or 3x plus 4. This quantity could be a positive 1 and it would check. Or this quantity, 2x plus 1 over 3x plus 4, could be a negative 1. And then we would solve these for x. So I'm going to multiply the first one by 3x plus 4. So I'm multiplying both sides. So I'm multiplying this side and this side. So when I multiply the left side, the 3x plus 4 cancels. So that leaves me with 2x plus 1. On the right side, it's 1 times that 3x plus 1. So that's going to be 3x. Or 3x plus 4 rather. So it'll be 3x plus 4 over here. So solving this for x here, let's go ahead and just bring this over to this side, change the sign, and bring this over to this side, change the sign. So 3x over here, because it's minus 3x and 2x is a minus x, equals, bring this over, that'd be a minus 1, 4 and minus 1, it gives me a 3. Multiply by a negative 1 here to solve for x. I get x is equal to a negative 3. So that's one possible solution. Now for the next one again, same thing, except it's a negative 1. So multiply both sides by 3x plus 4. That's going to give me a 2x plus 1. Multiply by 3x plus 4. Cancel it over here. And then on the right side, you multiply it by a negative 1. So this would be a negative 3x minus 4. Let's bring this over to this side. Plus 3x and a 2x gives me a 5x. Take this over to the other side. Let's say negative 1 and minus 4 is a negative 5. Divide through by 5 here. This is negative 5 over 5. That's a negative 1. So your possible solutions then would be x equal negative 3 or negative 1. And then you would check this. So let's do the negative 3. So it's negative 3 here for the x's. That's negative 6 and 1. That's a negative 5. And on the bottom, that's negative 3 here is negative 9, and 4 and 4 is a negative 5, and those divide out. So again, plug it in negative 3, I get negative 6 and 1 is negative 5. Negative 3 here is negative 9 and 4 is negative 5. That's a 1. Absolute value of 1 is what I have on the right side, which is 1. So that checks out. And then let's do the negative 1. negative 1 here in the numerator. That's negative 1 times 2 is negative 1, negative 2, and 1 is a negative 1. And then negative 1 here is negative 3, and 4 is a positive 1. Negative 1 divided by 1 is a negative 1, but the absolute value of that is positive 1, which is what I have on the right side. So let's check out. And then in the last one, we have the absolute value of x squared plus 3x is equal to x squared minus 2x. So this one has two absolute values. So let's set it up this way. It could turn out that both of these quantities are positive, or it could turn out that they're both negative. Or one could be positive and one could be negative. But the absolute value will guarantee that the value of the expression will be a non-negative number. So let's do it this way then. Let's suppose they're both positive. If they're both positive, then the absolute value of x squared plus 3x would be just x squared plus 3x. And the same thing on the right side. It's positive, you just remove the absolute values. So we get that. Now the other possibility it could be is that they're both negative. So if they're both negative, then we just put the expression with a negative in front of this one. So in other words, it would be like this. So again, if they're both positive, it's x squared plus 3x is equal to x squared minus 2x. If they're both negative, then to remove the absolute values, I have to put a negative here and a negative here. But notice, because I have a negative and a negative, they just cancel out. So either way, I still get the same thing. X squared plus 3x is equal to x squared minus 2x. And then we would just solve this. Now the other case would be then, so we enter the case where they're both positive or both negative. Now if one's positive and the other one is negative, then we'd have this situation. So it would be, okay, let's suppose the first one here, x squared plus 3x comes out negative. Then this would be a minus x squared plus 3x. And then since this is positive, then the absolute value of positive is the positive. So I just remove the absolute values. So again, if the one on the left side, x squared plus 3x is negative, to remove the absolute values, I have to put a negative here. If the x squared minus 2x is positive, then okay, I just remove the absolute values. If it's the other way around, then the negative's on the right side, and this one doesn't have a negative. Either way, the negatives cancel. So I'm still going to have the same equation. And this was a minus here. So all I would have then, if one is negative and the other one is not, talking about what's inside the absolute values, one negative would be on either the left side or the right side. Doesn't matter where you put it. It's the same equation. So I'll put it on the left side. Then we just solve this first one here for x. So notice the x squared and the x squared cancels. And I get 3x minus 2x. So let's bring that over to the other side. That'll give me a 5x equal to 0. Divide through by 5. This cancels out. So I get then the one possible solution then would be that x is equal to 0. And notice that you can check that very easily here before we complete it here. Because I put a 0 there and a 0 there, that's 0, absolute value of 0 is 0. Put a 0 there, a 0 there, absolute value of 0 is 0. That one checks. So for this one here, multiply through by the negative, I get a minus x squared minus 2 is equal to x squared minus 2x. Let's bring everything to one side. So let's do it this way. Either way, it doesn't matter. I'm going to bring this one over to this side. It'd be a plus x squared and x squared, that's 2x squared. And there should be a 3x here. Then we apply the negative here. Minus x squared and a minus 3x right here. So I'm going to bring everything to the right side. So this is going to be 0 here. This comes over becomes a plus x squared and a 1x squared. That will be a 2x squared. And then this comes over, that's a plus 3x, and a minus 2 is a minus x. And then we just factor this. Take out an x, leaves you with 2x minus 1. Okay, we set each factor equal to 0, so this won't give me that x is equal to 0. I already have that one over here, so I don't have to put it again. And then 2x minus 1 can be 0. Add 1 to both sides, I get 2x equal to 1. Divide both sides by 2, and I get 1/2. Got the sign wrong in this one. When I took this over to this side, this was a plus 1x, so this is a plus here. This is a plus here. And when I said this is equal to 0, this is a plus, so this will be a negative right here. So the answer to this one then is x can be 0 or x can be a negative 1/2. And we check the 0, you can go ahead and plug in the minus 1/2 on both sides of this equation here for number 5, and you should get the same value on each side to confirm that they're both solutions. Thanks for watching. We'll see you next time.